Hi folks, welcome back. I hope you're all doing well. On this channel, we've taken a look at many papers that examine the impact of large language models on the teaching of computer science, the teaching of introductory programming. A while ago, we looked at a paper that examined how Codex, which is the LLM behind GitHub's Copilot, can be used to solve CS 101 Introduction to Programming type of questions. And this paper we're looking at today, which is by some of the same authors, looks at the same question but for CS2, which is the successor course. It looks at data structures and algorithms and has more challenging problems. The setup is pretty simple. They take questions from previous CS2 exams and give it to Codex to solve, just the plain English language questions. And just to recap, what they found previously with CS1 was that Codex scored about 80% on the two tests that it was given and landed in the top quartile of the class. So that was pretty good. They have a couple of examples of the kinds of questions that appear in CS2. This one over here asks to write a recursive function that takes a list of integers and returns the same list but with the largest integer in the last position. And then we have another example here which takes a list of strings and asks to return a list of tuples with each tuple being the string and its length. But those are some of the simpler questions. There are more challenging questions in the question set. So let's get right to the results. They compared the results of Codex to a cohort of about 200 students. This table shows the scores achieved by Copilot compared to the average score achieved by that cohort of students. And Copilot was subject to the same rules in that you submit your code to a battery of automated unit tests and the scoring is all or nothing. If all the unit tests pass, you get full points for that question. If there's even one failure, you get no credit. You can submit repeated attempts, but there are penalties for repeated failed attempts. And so on test 1, you see that the average score of the students was 51%. The average score for Codex was 76%. On test 2, which has more advanced topics, the students came in at 45% and Codex came in at 55%. This graph shows the distribution in a bit more detail. Test 1 is on the x-axis, test 2 is on the y-axis, and this orange X is Copilot. And in this cohort of about 200 students, Copilot managed to get just into the top quartile. One interesting thing to note is the distribution of scores. In these graphs, you can see that distribution not just on CS2, but also the CS1 tests. And you can see how in CS1, it had a lot of high scores and some low scores. Same thing for test 1 of CS2. Whereas on test 2, which was the more challenging one, the scores are much more even in that it had as many low scoring attempts as high scoring attempts. So overall, it still managed to land in the top quartile for CS2, but it had a much tougher time. It did it much more easily for CS1 than for CS2. Another interesting thing to note was how prompt length, which is basically the length of the question, affected the score. And you can see that shorter prompts of about 700 characters ended up scoring really high, and most of the lower scoring questions were those that had much longer prompts. Now, one interpretation of this is, well, obviously the more challenging questions had longer descriptions and hence Codex had a tougher time solving them, which is true. Also, the authors note that the longer, more challenging questions had pieces of code in the question itself, and the question asked to either add to that code or modify that code in some way. Not surprisingly, the questions where Copilot performed poorly had a lot of edge cases, needed to operate on complex data, or asked for specific output formats. So it still had some trouble with the more challenging question. So TLDR, Even on CS2, Codex ended up in the top quartile of the class, similar to how it performed in CS1, though it had a much easier time in CS1. The big open question most of these papers end with is, well, what does all this mean for the teaching of computer science and the teaching of introductory programming? And I don't think anyone has a great answer yet. All this is so new that teachers, instructors, and the designers of curricula are still grappling with this question. It seems pretty obvious that these tools will only get better, more accessible, and be able to tackle more and more challenging problems. And so this is something we do need to figure out. How do we teach computer science with tools like this? One idea that keeps coming up again and again is to shift the focus away from only writing code towards reading and understanding and critiquing code. But overall, this is still an open question. So that was a quick look at a paper that examines how Copilot or Codex can solve CS2 questions. That's data structures and algorithms, and it did pretty well. If you like content like this, please like the video, consider subscribing, and I will see you all next time. Thank you very much.